this with me. What I want to do is I want to put the I don't want to erase that. I want to put it here and erase this instead. Oh my goodness. It's not like a good shot. Okay. First thing, get to the home screen. Get to the home screen. Left parentheses. Okay? Vars button. Right arrow. Function. Enter. It now says Y1 right there. Okay. What the TI wants you to do right now is it wants you to give it an X value. So if you're thinking about how you guys were calculating this average rate of change, the first Y value you put in was the 200. That is the Y value at, you need to go around, don't you? The Y value, excuse me, at 10.3. Now when you type that in the TI, what the TI will do, let me just show you actually. You don't hit enter, I'm going to show you what it's going to do. When you press enter, the TI knows that's about 200 feet, because we know that. That's the point, 10.3 comma 200 up on the top. So we know that for a fact, yes? For a fact. So when you have it like you do in your little expression right there, we can then subtract from that, minus, get that Y1 again. Everybody catching the Y1? It's the same button pushes you use to get Y1 when you're doing the linear regressions and quadratic regressions. So vars, it's the same Y1 you got, it's the same one from the booklet. Vars, right, arrow, arrow. It's the same exact button pushes, yes? Now, put in your second time, which in this case is 7.5. So what this is doing is, it's doing the same thing you do. It's subtracting the two Y values. But it's subtracting the two Y values at 10.3 seconds and at 7.5 seconds. It's doing it in symbolic form. I know you're questioning why I'm making you do this. Hold tight. I'll show you why momentarily. I'll show you why momentarily. That's the top of the fraction, the slope fraction. If I pressed enter right now, that number might sound familiar to you. I hope you didn't press enter. If you did, it's okay. We can go back. Remember what Frances said when she did those two subtractions? She got 89.8. That's what I got right here. That's how much distance I covered. Now, you guys are still sitting at this right here. That's just the feet. Now hit divide by left parentheses. What do you think's going to go down here? Not Y2. This is the denominator of that fraction. What was in the denominator of all these fractions?
10.3.
Yes, 10.3 minus 7.5. In other words, the top is feet and the bottom is time. Feet over time. That sounds like everything we've been doing. Feet over time. Feet over time. Y2 minus Y1 over X2 minus X1. You see? Y2 minus Y1 over X2 minus X1. What you're learning here is you're learning how to make the TI do that. You're learning how to make the TI do that. The TI can do it just like this. So now when you press enter, it comes back with 160.8.
Yeah.
Why do we have 10.3, 7.5?
Yeah, why do we have that twice?
Oh, no, we don't have that twice. We have the Y value at 10.3 minus the Y value at 7.5 over the X value of 10.3 minus the X value of 7.5. However, I've got a problem with this.
Did you put another parentheses?
Oh, time out. Wait a minute. Hang on.
I still get 160.
No, thank you. That was my mistake. My mistake was parentheses. Sorry. Press second enter to get that whole thing back. Thank you for that. Thank you for that.
I times all that. Yeah.
You need to have another set of parentheses right here. My apologies. Thank you. Good. Does everybody know how to insert something into a line of code? You learned this at 95, I hope. Second enter, and you can just drop it in like that. Is that? See what I just did? Put in the you also can just erase it and to retype the entire thing. It's one of those Math 95 things.
Mine still says invalid.
Oh no! Well, invalid. That's a data entry error. We can deal with that after class. That's from way back in the beginning. Now, does this number sound familiar to what Francis told us? 32.1. That's my average speed. That's my average speed between 7.5 seconds and 10.3 seconds. About 32.1 miles per hour. It sounds like we don't like this very much. Okay. That's okay. That's okay. The reason, can I show you why I kind of like it? Now, that's still not how fast I was going at 200 feet. But it's getting closer to how fast I was going at 200 feet. So what should I do at this point now? Move it even closer. Now we can't move it all the way, can we? Remember, if we move it all the way to that point, what happens?
10 seconds.
We get, say it again.
Move to like 10 seconds.
Okay, good. So Blake say move to like 10 seconds instead of 10.3. If you go to 10.3, we get an undefined situation. The reason I like doing it this way is now, suppose we go up to 8 seconds instead of 7.5. All I've got to do, and again, this might not be worth your time to do, I press second enter and I just change the 7.5s to 8.
Yeah, except for erases everything.
No, it doesn't. It keeps everything, and then I press enter again, and it's about 32.9. That's why I like this. I can just change those two end values. Hopefully you guys are realizing this is going to be 200, and this is going to be 10.3 every single time. All I can do is go in and change these numbers here to whatever I need to frame of reference I need to do with. But this might be more trouble than it's worth. I'm getting the looks I'm getting are saying like I wish you hadn't even started talking about this. Chad, go ahead.
I'm just wondering why. So you're wanting to know how fast you're going at the end there. I don't understand why you're not just measuring the distance between the last 25 feet.
Hold that thought, please. Hold that thought, Chad, if you will. We are getting there. So here's the deal, and this is what I have an in-class quiz for you guys to do to finish this off. Let's go back to the graph. I love what you just said, Chad, and I think hopefully some of you are thinking the exact same thing. It seems like we're doing an awful lot of work to not get the answer we need. So here's the deal. Remember what I said before about these